Welcome viewers, in this video we will see the design of 1-bit digital comparator using logic gates. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic. We need to design the 1-bit digital comparator using the logic gates. So consider a two 1-bit number A and B. Two numbers A and B having only 1 bit, right? The truth table is shown below. So the input is A and B, the number A and number B having only 1 bit, right? So due to the number 2, A and B, we have 4 combinations are available. 0, 0, 0, 1, 1, 0, 1, 1. That is A is 0, B is also 0. A is 0, B is 1. A is 1, B is 0. Both are 1, 1, right? Only 1 bit is there. 2-bit digital comparator, 4-bit digital comparator available separate video. Link is available in the description box. This is having only 1 bit, right? So what is the output? There are 3 possible outputs are there. A equal to B. But the number A is equal to number B. Then A greater than B or A less than B. There are 3 possibilities are available. So by comparing the number, we can identify whether it is A is equal to B or A is less than B or A is greater than B. So 0, 0, A also 0, B also 0 means both are equal. So A equal to 1. So this is 1. Remainings are zeros. 0, 1. So by seeing this number, we can easily see that A is lesser and B is greater, right? So that this third column is 1. A less than B. It means B is greater. 1, 0. 1, 0 means A is greater, B is lesser, right? So this is 1. A greater than B. This corresponding second column is 1. 1, 1. Both are 1, 1, right? It means both are equal. A equal to B, right? So here there are 2 possibilities. There is 0, 0 and 1, 1 having both are equal. 0, 1 means B is greater. 1, 0 means A is greater, right? Now we got the truth table. From this truth table, that is 3 possibilities: A equal to B, A greater than B, A less than B. For that, we need to frame the Boolean function, so that Boolean function can be implemented with the logic gates. The Boolean function we can write it from this tabular column, or also using K map also we can obtain the Boolean function. See this from this tabular column. This for A equal to B, the first is 1 and last is 1. First is 1 mean what is the corresponding available here? 0, 0. 0 means A bar, B bar, right? So that is K map also available and a normal value also available. See this A bar, B bar. This last one also 1. That is 1, 1. 1, 1 means AB. So that's AB. We will see this K map later. Directly from the truth table, we can write this 1 means 0, 0. 0, 0 means A bar, B bar. Here also 1. 1, 1 means AB. So that is written here. A bar, B bar plus AB, right? Similarly, for A greater than, this is the 1. What is available corresponding input? 1, 0. 1, 0 means A, B bar. A greater than is A, B bar. This is available. A, B bar. So this is the A, B bar, right? Similarly, A less than B. This is 1. What is the corresponding input? 0, 1. 0, 1 means A bar, B. A bar, B, right? So for A equal to B, A bar, B bar plus AB. A greater than B, A, B bar. A less than B, A bar, B, right? The same thing can be implemented with the Boolean, the K map also, Karnaugh map. For A equal to B. So this is the 2 variable K map. A and B, 2 inputs A and B. So A having 2 possibilities, 0, 1. B also having 2 possibilities, 0, 1. Right. From the table we can mark it as 0, 0. For 0, 0 it is 1. For 1, 1 it is 1. Right. So these two, 0, 0 and 1, 1. So the first cell is 0, 0. Second cell is 0, 1. Third cell is 1, 0. Fourth cell is 1, 1. So 0, 0 and 1, 1 having 1. Remainings are 0. Right. What is corresponding row and column? Again it is 0, 0. 0, 0 means A bar, B bar. Here what is corresponding column and row? 1, 1. 1, 1 means AB. Right. So this A bar, B bar plus AB, that can be written as, that is nothing but a exclusive NOR gate. A bar, B bar plus A bar, AB is nothing but exclusive NOR gate of input A and B. right. So, by using the exclusive NOR gate, we can implement this function for A equal to B. Then, now we will go to A greater than B, right. So, this is the only term, only one. From the tabular column we can write 1 0, 1 0 having 1. This is 1 0. 1 0 means A B bar. For A less than B, this is the only term 0 1. So, this 0 1 corresponding 0 1 having 1. What is 0 1? 0 1 means A bar B, right. Now, we got the expression for A equal to B, A greater than B, A less than B, right. For A equal to B, we need one XOR gate. A greater than B, A B bar, A less than B, A bar B, right. Now, we can implement this with the logic gates. So, here the logic gate diagram is available, the two inputs A and B, right. So, for A greater than B, what we need is A B bar, A and B bar. So, that is we need one AND gate, right. So, A is connected directly. We need B bar, B is available here. So, B is tapping is taken, input B is taken, that is connected with the one NOT gate, then it is connected to this AND gate. So, that here B means after NOT gate it got B bar. So, the input to this AND gate is A B bar. So, the output will be A into B bar, that is nothing but A greater than B, logical expression for A greater than B, right. So, A is connected directly, B is connected through the NOT gate, so that we got B bar. For A equal to B, what we need is exclusive NOR gate. So, this is the exclusive NOR gate, right. So, the A is connected directly, B is also connected directly, right. So, A connected like this, B connected like this. So, that what we got A exclusive NOR of B. So, that it is the equivalent to the A equal to B. Then for A less than B, what is the requirement? A bar B, A bar B, right. So, B is connected directly, A is connected through the NOT gate, right. A is available here, the input A is taken, that is connected to the NOT gate. So, that we got A bar. One input is B, another input is A. So, due to the AND gate it will give A bar B. Now, we got the expression for A bar B. So, it will give the value A less than B, right. Now, we have three outputs, A greater than B, A equal to B, A less than B. Depends upon the value of A and B, correspondingly all terms are connected together. So, based on the value of A and B, any one output will be higher, either A greater than B or A equal to B or A less than B, based on the value, right. So, in this video we discuss about the 1-bit digital comparator. First we will discuss the truth table. From the truth table, using K-map, reduced Boolean function is obtained. That Boolean function is implemented with the logic gates. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. Link is given in the description box. Thank you for listening.